All right, so we're going to start now. What I have is, and I'm actually starting all over from the very beginning. What I'm going to do is we're going to give some example questions about multiplication of fractions, and then also we're going to move into division of fractions. So this is section 6.2 and 6.3, and then I have an assignment after that. What I'm going to do is I'll post the questions on my essay before the end of the class so that you have those questions available to you. So what's that? We're not going to collect the homework. If there's any other questions that you have on the homework, I'll be glad to go over them right now. So does anyone have any, what you just did in the form of a quiz is going to be your homework for now? What's that? Yes, I mean, sure. So the answer to question number 23 on the homework was, should be, where is it? That's okay. It's, wait, go ahead, say it. Okay, let me go ahead and do 23. Oh, got it. So what? How did you do that one?
I factored the part out and then the one down. Like
all right, so let's.
First, you have to rearrange the part out because it says like 10 minus 3a minus a.
Okay, so number 23, which is the bonus question, said 10 minus 3a minus a squared over a squared minus 4, and so. Probably for us, the easiest way to do this would be to change the order of the top one. Yeah. And then also, if we multiply the top and the bottom by, we could also factor out a -1. But let's go ahead and do that first. So I'm going to have minus a squared minus 3a plus 10 all over a squared minus 4. Now, we don't typically factor, the reason this is a bonus question is because we don't typically factor these with a minus sign in the front of them, but we can remove that by factoring it out and just, say it again?
A squared plus 3a minus 10.
Exactly, plus 3a minus 10. And so now we can factor that. And again, we can also still factor the bottom. But let's go ahead and let's see if we can't factor. So let's go back up here. So we got a minus sign, and we're going to factor it into 2. Now, the reason I am not splitting the middle term is I want you to start learning that if there's no number, if there's only a 1, you guys see where this mark here? Yeah. If that little space is a 1, then we can use the numbers that we would otherwise use to split the middle term, and we place them directly in there. We're done. So we're just looking for 2 numbers that multiply to -10 and add to +3.
A plus 5,
and say it again. A plus what?
Plus 5, a minus 2.
A plus 5 and a minus 2. And then this is going to be over. Can you factor a minus 4? A minus 2 times a plus 2. Do any of these factors cancel? Before I do that, though, now that it's factored, what do I need to do? I need to cite the restrictions, correct? Yeah. So what are the 2 values that a cannot equal? Cannot equal 2 or? -2. Remember, it's only the denominator that we're dealing with. And so those are our restrictions. I'm going to reduce these, and my final answer is just going to be negative. You could just write it this way is fine, or you could distribute the negative sign, but that's it. Okay? So that's the bonus question, and I didn't count it as a bonus question though too. Who got that one? Okay, at one point we're going to have a break, and you guys are going to just show it to me, and I'll see if I can't give you credit for that. Did you get the answer right?
Yeah.
You get the answer right too? Did you do it? Did anyone do it any differently? It is possible to factor it as it sat, but it's. I think it's easier to just do how we did it. How about you, Celine? Did you do it any different, or was that pretty similar to what you did? All right, you too, Ben? Okay, excellent. Okay, so what we're going to do right now is I'm going to give you some problems I want to walk you through them, and then we're going to ask you guys to do some practice ones on the board. So let's go to the next. So what we're going to do right now, this is section 6.2, and it's called multiplying fractions. So what we're going to do is, it's going to be interestingly very similar to what we've done. You've done in the past. Let's look at a problem. Let's look at 8/9 times 3/10. So what do we do when we're multiplying fractions? Before we multiply fractions, there's a little technique we use to simplify things first. And what was that? Right. So you can divide out common factors on the top and the bottom, just like we do when we simplify. Which common factors do we have?
3 and 9.
So we have 3 and 9. So it can divide the 9 by 3 and we get 3. Divide the 3 by 3 and we get 1. What else? 8 and 10. Divide that by 2, you get 4. Divide that by 2, you get 5. Final answer is going to be 4 over what? Over 15. Question: Could I have done the following? Could I have also just multiplied them out? So let's do the same. Let's do the same thing another way. Let's go 8/9 times 3/10. What does that equal? Could I just multiply it out without simplifying? Yeah, and I would write 24 over 90. And then I would have to figure out the common factor that they both have and reduce it. And so in this case, they both have a common factor of 3 to 6, I think. 90 goes into 6. 90, okay.
Yeah.
6 goes into 24 how many times?
4.
And 6 goes into 90, it goes in 15 times. So the idea is this. We can solve these problems. This is a basic one to show us, two things. One is that we can divide out the common factors, or we can multiply and then reduce. What's the advantage of number one, though? What's the advantage of reducing it first? It's faster and it keeps the numbers down, doesn't it? Right? It's not so easy to figure out what the greatest common factor is of 24 and 90, but it's easy to figure out that 3 goes into 9 and 3. But are you wrong on either? Are you wrong in either way? And the answer is no. Okay. So let's go to one that's a little bit more varsity for us. You ready? Let's go. My example 2. So we're going to use less space. So this next problem is going to have some variables. So I got 6x over y to the third times y squared over 15. So again, because everything is multiplication, what we can do is divide out common factors on the top and the bottom. So, or cancel out. I know we use the word cancel out. I just want to make sure you know that what we're really doing is not canceling them and removing them from existence. What we're doing is we're reducing them by common factors. Notice there's 2 factors of y on the top, and there's 3 factors of y on the bottom, right? So we could definitely cancel out some y's. And how about what else?
3.
Guys, shut your computers, right? Take your notebooks out.
3.
3. So I can divide the 6 by 3, and I get what? 2. Divide the 15 by 3.
5.
Okay, now x squared. I'm going to divide the top by y squared. Divide the top by y squared, and I get what? 1. If I divide the bottom by y squared, I get y. And I think that's all we can do. Once we're done reducing, what we're going to do is multiply across everything we have. Does everyone see that x down there? It didn't disappear, did it? So we have on the top,
X down.
we have 2x on the top. Let me get my little name caller thing here. And over what? 5y. Perfect. And that's your answer, all right? So what's going to have you? What's that?
How would you check it? Like,
How can you check that you got the right answer?
yeah,
If I didn't give it to you?
yeah, like on a test.
Oh, I don't know. It's not as easy as like when oftentimes when you solve for x or something, you can plug in the value of x to check it. On something like this, I'm not sure if there's any really straightforward way of making sure that you're correct, except to go back and make sure that you canceled correctly. All right, to go back, and I think sometimes what happens sometimes when we're canceling like this is like we forget that little x. You see how the x didn't nothing happened to the x. It's like sitting down there, and you sometimes just miss it by reading it. But I would just go back and make sure that you cancel correctly, that you divide it out correctly. So let's go to a. All right. So next step. All right. This is the big problem. This is the one that you need to definitely know. If you can know this one well, you're going to be in a good place. So here's my next one is going to be x squared minus x minus 12 over x squared minus 5x times x squared minus 25 over x plus 3. Very you go. So we need to factor these. Again, I'm hoping you understand. Joseph, when I factor, I just want you to remember, because we talked about this once before, only if there's no number bigger than 1 in front of this x squared term can we split the term and the actual split numbers go right into the parentheses, right? So this factoring is one step, all right? Should be one step for us. If there was a 2 in front of there, is that the same? No, then we need to split the middle term. If there's a 3 there, 4 there, we need to split the middle term, unless we can guess ourselves. But when there is none in there, we should be able to factor it a lot quicker than splitting the middle term. So I'm going to start doing that so that we can get used to the easy ones. So when we do the first one, we're going to go, what two numbers multiply? I mean, we can make the x. That's okay, actually. You could make the x, and if you want to, and write negative 12 on the top and negative 1 on the bottom. But actually, that's not a bad idea. Do you like, but the point is, we don't have to go through the rest of the steps. Let me get my little eraser here. Okay, so, what did you say? You said it already. Negative 4 and 3. So you're going to say x minus 4, x plus 3. Check your numbers. You're going to go negative 4 and plus 3. Does that negative 1? Yeah? And negative 4 times positive 3, is that negative 12? Yes. So we did it right. So next one, the bottom. How do we factor the bottom one? Tommy's not here. Hi, Tommy. Gabby, how about the bottom one? X squared minus 5x.
X minus 5.
Correct. X times x minus 5?
And then X plus 5.
No, on this one, you don't have to do that. Okay? This isn't, it looks like a difference of 2 squares, but this one's not a perfect.
The other one.
Right. So we're just taking out the greatest common factor. But this one up there, you're right. Almost done. Okay, so go ahead, Gabby. Gabby's got the top one here. It's going to be x plus 5 times x minus 5. And then we have x plus 3 on the bottom. Okay, ready. Now that it's all factored, prior to it being factored, everything was just one factor on the top, one factor on the bottom, right? And as one factor, they have to be alike to be canceled. So there's nothing we can do in its first form. But once we factored it, now we can see that there are common factors inside. What common factors do we have?
5.
X minus 5. And x plus 5?
X plus 3.
X plus 3. And is there anything left? And that's it. Final answer, therefore, is going to be x minus 4 times x plus 5 over what? over x. The one last thing that we didn't do is what? What should we have done here that didn't happen? Ben? What should we have done on that second step right here? What did we not do here?
We for x is not equal negative.
Yeah, what values can x not equal?
Negative 5.
It-
No,
It can't equal positive 5.
positive 5.
It can't equal negative 3. And one more.
Positive 4.
Negative.
You just have this, guys. You have the x minus 5 and the x plus 3. So if you put a negative 3 here, negative 3 plus 3 is 0. Bad, right?
Yes.
So that's my negative 3. 5 minus 5 is 0, right?
Yes.
So that could also cause an explosion. The other one too is, what if just x is equal to 0 for here? Put a 0 right in there for that. Does that produce 0 in the bottom too?
You can do that.
Yeah, I mean, it's possible. I'm just saying we can't allow 0 to, basically it's to say I can't plug in 0 into this equation. Not allowed. All right, so I can plug in any number in the universe except those three numbers, 5, negative 3, and 0.
Why isn't it negative 5 as well?
What's that?
Why isn't it negative 5 as well?
Why isn't it negative 5?
So just, it's both negative, yeah, so negative.
Because,
But then it'd be negative 5 plus 5, which is equal to 0.
correct.
But,
That's exactly right.
so why isn't negative 5 not? That's not, you can't.
Well, negative 5 minus 5 is negative 10.
Yeah.
So that doesn't produce 0. We only want the values for x that could create a 0 in the denominator.
Oh, in the denominator.
Right.
Okay.
Not in the top.
Oh,
Okay.
why isn't it on the top?
Okay, that's one of the things, two things I asked you to do yesterday. Yesterday I asked you to take 0 and divide it by 3, and I asked you what is 0 divided by 3?
Error.
Is it?
0. Oh, 0 divided by 3.
0 divided by 3 is not an error. That's just equal to 0.
I thought you said 3.
So, and that's fine. I know how much people don't like zeros, but the thing is, 0 is a number. It is a real number. It exists on the number line, right? So it's fine. Algebra has no problems with zeros in the top. But it's when you put the 0 on the bottom that we had all hell breaking loose, right? Put 0 on the bottom, basically that means infinity. So they're opposites, aren't they? This means 0, this means infinity. And infinities are not allowed. They're not numbers. And we use the term, in fact, called it undefined, right? Because no one really can comprehend infinity, right? So it's the zeros in the denominator, again, that we have to be concerned with. And I think the great, for me, the great place where you see this now is in coding. And it's very easy because we do, there's lots of numbers that go into coding. And the thing is, when you create your tree, when you create your Mario, you're creating it mathematically. And you need to make sure that zeros never occur in the denominator or the computer crashes. All right? It tries to calculate infinity. It doesn't want to do that. No matter how great calculators are or computers, they're not able to deal with infinities. So they stop. So anyway, that's for me the greatest application of it, but mathematically we have to be aware of it too. Remember the graphs? At those places the graph kind of went nutty, didn't it? Went straight up or straight down, went crazy. All right, so it's important for pre-calculus too that we understand that those numbers actually have meaning. Later on when we graph that, you see that at these points, at 5, negative 3, and 0, crazy things are happening. Almost always. All right? Or in some cases, it just like puts a hole in the graph. Just like, it's like a smooth graph, and that's just like a hole, this missing dot, this missing point. So let's move on. What I want to do right now is I want you to practice a couple. I'm going to put some on the board and give you an opportunity to practice these. So if you guys could stand up, grab a marker, find a place on the board. I'll put a problem on the board, and you guys can try to do it. Ready? Let's work our way up. 3 to 27. Okay. You guys want to start with a nice one? A kind one? A gentle one? Okay. Here it is. So here's your practice. And for you hockey players, I would love it if you just get a piece of paper, a pencil, pause for now, get a piece of paper and a pencil, write this thing down, and go ahead and practice each one of these. So your practice is going to be, guys, calm down here. 4 ninths times 3 sixteenths. 4 ninths times 3 sixteenths. And I'll pause now. You guys can pause that are listening to this thing and see if you can't follow it. Okay, that was very impressive, everybody. That's the answer is 1 over 12. Let's go ahead and step it up a little bit. I'm going to go to. All right. Okay, so here it is 6a divided by 11b to the fourth times 22b over 3a to the third. All right, I'm going to,
Is that 11B?
hockey boys, I'm going to pause you guys and we'll come back. Okay. So yeah, guys, final answer 4 over a squared b to the third. All right, you guys are cooking with gas. Let me try. This is here's a sneaky one. See if you can figure this one out. 2n over 7.
That was a complete game.
Okay, before we go too far, I have 2n over 7 squared. We didn't talk about this yet, but do you think you guys can figure out how to do that? Wow, how did you know that, Celine? Wait, what's that? Yeah,
No. That was already written down here.
She's right.
It was right here in blue.
Done.
I
Let me see, what'd you get?
Oh.
Who wrote? Okay. So so basically what did you guys do?
You just have to multiply everything.
Ben, copy it.
Square everything inside the
Ben, stop cheating.
Right. And that means this. It means squaring the 2 and squaring the n, right? And then squaring the 7. So you squared 3 things. Wow. That was pretty good. So, okay. All right. Yeah, so the final answer is 4n squared over 49. All right, guys. Now we're going to get...
What is it?
You got it? Okay. So, let's go to... you guys are making me think I'm babying you too much, so let's try this one. Let's try one. I got 2 more, and I think we're going to be in... we should be able to start our homework and get a good job on it. So, here is 3x. Oh, I like this one. 3x over y to the 3rd power times y squared over 9. Can I just cancel the y's out as it sits there? No, you can't. Why can't I not reduce the 3's and the 9's? Why? What do I have to do first? You're all doing it right.
No.
Whoa, careful.
Messed up.
Guys, what's 3 cubed?
27.
Ah, it's 27, right? It's 3 times 3 times 3.
I got the answer. Mr. Shai.
Joey, don't write 9. 3
Oh, my bad.
3 cubed is what?
That's the answer.
Think of it. 3 times 3. There you go.
Mr. Shai, the answer.
I think that may be pretty darn close to correct. Let me see. Let me see. No.
Ben, stop.
No.
This way, Mr. Shai, is that a...
That is correct.
Why you got no?
Sasso is correct.
Oh, I got it.
And
3 over y.
3x over y. 3x over y. Mr. Shai,
yeah.
Mr. Shai, am I right now?
No, you need a couple more X's there.
You have the worst
Oh.
You have
Okay.
3x squared.
Sorry.
Okay, Joey England. All right.
Done.
You're not done yet. You're getting there, though. Okay. How many people got this far? 27x cubed. That's correct. Celine's got it. 27. Always be careful. 3 cubed. That's the algebra 1 error. It's like 9, right? No, it's 3 times 3 times 3 is 27. X times x cubed is x cubed. And then y cubed. Did you guys cube everything, right?
Yes.
Y squared over 9. Now we can divide out common factors. So what can we divide out?
9.
9.
1.
The 9 divides out, becomes 1, and up here becomes 3. What else divides out? Hey,
Y sub to the second.
Y squared.
y squared. Y squared will go out with a y3. I divide the y squared by y squared, I get 1. Y to the third divided by y squared. What
Sorry.
do you think, you're in your house or something? Okay, it gives me what? Guys are moving. Oh,
Oh, and I saw it.